This video will introduce the Pest Analytical Communication Tool, or PestACT, an interactive decision support tool for invasive pests. In PestACT, new infections are placed by selecting Place Infection and clicking on the map. In this example, PestACT simulates the spread of fire blight, a disease affecting apples and pears using actual land cover data from a 300 square mile region in Australia. Fire blight spreads one of two ways. During rainstorms, splash dispersal can spread the disease relatively short distances. Over longer distances, bees can spread fire blight as far as they can disperse, upwards of 3 kilometers. In the map, areas in yellow represent pear orchards and areas in green apples. Areas in white and black are non-host land cover. PestACT works on weekly time steps, which you can see progress here. When the plant becomes susceptible to the disease during flushing around week 40, you'll notice new infections occurring on the map, which appear as red dots. Undetected infections appear as blue polygons. By pressing Run again, I can pause the incursion so we can stop for evaluation. You'll see that fire blight has spread from the initial infestation to a somewhat larger region. Now is the time to start making management decisions. First, I'll turn on the Auto Management button, which applies my management decision each time a new incursion is detected. Also, I'll choose to impose a quarantine and eradication program, but because I'm not sure of the optimal radius, I simply select the smallest value for each. After making these changes, I click the Run button again and the model begins where it left off. Notice now that areas in gray and black are appearing on the map. Gray represents the quarantine area and black the eradication zone. With oversight by regulatory officials in the form of quarantine and eradication, costs associated with the infestation are beginning to mount. Also notice that growers in the region are beginning to feel the impacts of yield reductions, which are calculated based on the number of infected trees and estimates of their productivity. Importantly, PestACT allows the users to examine the trade-offs and uncertainties of different management decisions. We'll now adjust the quarantine and eradication size to make them larger and see if new management strategies are more effective. So far in this scenario, we demonstrated a small radius for quarantine and eradication and found that this did not prevent the spread of the pest. We're optimistic that a larger radius for each will prevent the spread of the pest, but also suspect that the cost of the response program will increase. With larger quarantine eradication sizes, you'll notice that the spread of fire blight is better contained, but the response costs have increased. In future simulations, the size of the quarantine and eradication areas can be expanded or contracted for comparison, allowing incident responders to arrive at an optimal management solution. Here you see the output of a different PestACT model run for fire blight in Australia projected onto Google Earth imagery. Notice the extent of the infestation. Areas in blue represent the quarantine zone, and areas in red represent undetected infections. Yellow is detected infections, and magenta represents eradication zones. Viewing PestACT outputs like this can be a powerful means of communicating with PPQ stakeholders and help facilitate cooperation within and between emergency response teams, communities, and other stakeholder groups. Our project will modify PestACT for use in the U.S. as a generic tool. PestACT can be used for a variety of pests and pathogens that could affect U.S. agriculture. For example, PestACT could be used to examine the spread of spotted lanternfly on grapes in the Niagara region, a new invasive pecan pest in Georgia, the potential spread of Old World bollworm on cotton in Texas, or nearly any other commodity system. Ultimately, PestACT will help answer basic questions for new pest incursions. For instance, what are the benefits and costs of each management option, and how certain is it that the response option will be effective? Addressing these questions during pest incursions will help safeguard U.S. agriculture for generations to come.